Okay, right, welcome to part 2. Now, when you've got two lines in a two-dimensional space, there are three things that can happen with these two lines, okay? They can be intersecting, they can be parallel, or they can be coincident. A coincident just means that they're actually the same line, okay? And this is sort of intersecting each other at infinitely many points, okay? That is all that can happen in 2 dimensions. But in 3 dimensions, there is another option, okay? So in 3 dimensions, 2 lines can intersect, same as in 2 dimensions. They can be parallel, same as in 2 dimensions. They can be coincident, can be the same line, same as 2 dimensions, but they could also be skew, okay? Now, skew means they're not parallel, and they're not the same line, but also they don't intersect each other. You could imagine that what you've got a line here, and then you've another line that maybe goes behind it, but never touches it because it's set back in 3-dimensional space. I hope you understand what I mean by that. So you can have 2 lines that don't intersect each other at all, and they're not parallel. Okay, and they're not the same line. So we need to be able to find out what's happening with lines. Are they parallel? Are they skew? Or are they intersecting? Okay. So here we've got a question. We're basically going to find out what happens with each of those types. Okay. So we've got 3 lines: line 1, line 2, line 3. First part says show that line 1 and line 2 are parallel, but not coincident, okay? So let's just have a look at them. They've given them to us parametrically. So x equals minus 1 plus 2s, y equals 1 minus 2s, and z is equal to 1 plus 4s. So that's line 1. Line 2 is x equals 1 minus t, y equals t, z equals 3 minus 2t. So what we need to understand is what the direction vectors of these 2 lines are. Again, from the previous video, you should know that the direction vectors are the coefficients of the parameter. So that's 2, minus 2, 4 for line 1, and minus 1, 1, minus 2. Now, hopefully you'll notice that these 2 direction vectors are a multiple of each other, okay? I.e., if I multiply the direction vector of line 2 by minus 2, I get the direction vector of line 1. Now, this means, therefore, they are parallel or coincident. So they're either the same line or they're just parallel to each other. So how do we find out? What we do is we just pick a point, okay? Pick any point we like. So let's go for a point s equal, the point on line 1 where s equals 0. So that's going to give me the point minus 1, 1, 1. I picked 0 because it's just going to give me, it's the easiest one to calculate. So I know the point minus 1, 1 lies on line 1. What I'm going to do is simply check, does that lie on line 2? So if I go to line 2, I'm saying if x is minus 1, then t must be equal to 2. Okay? What about if y is equal to 1? I can see that y is equal to, to replace y with 1, I'll get 1 equals t, so t equals 1. And if I replace z with 1, I get 1 minus 3 minus 2t is equal, sorry, 1 is equal to 3 minus 2t. So 2t equals 2, so t equals 1. Now, what does that mean? How can we interpret that? Notice that I get a different value of t, or rather I don't get the same value of t for each one. Okay, so that means that the point minus 1, 1, 1, this point here, cannot lie on line 2. And since they are parallel or coincident, well, if they don't share a point, then they don't share any points. So therefore they must be parallel. So I can use this to conclude, therefore they are parallel. Okay, I hope that's clear. If they were coincident, these values of t would all be the same. They would all be t equals 1, t equals 2, or whatever. Then actually would be the same line. Okay, so I hope that makes sense. Please let me know if it doesn't. Right, let's do part B. Show that line 2 and line 3 intersect and find the angle between them. Okay, so line 2 and 3. So we've got, let's write them out again. X is equal to 1 minus t for line 2, y equals t, z equals 3 minus 2t. And for line 3, x equals 1 plus 2u, y equals minus 1 minus u, z equals 4 plus 3u. Now, if they are equal, if they intersect at a certain point, well, we can find out where that is by equating each parameter of the line. So we can say, what happens when when the two x values are equal? So 1 minus t equals 1 plus 2u. And what happens when the two y values are equal? Well, t would be equal to minus 1 minus u. And finally, when the two z values are equal to each other, 3 minus 2t would be equal to 4 plus 3u. So we've got some simultaneous equations here. All I need to do is take, because there's only two variables, so I can use, let's just call this equation 1, 2 and 3. I only need to use equations 1 and 2 to solve it, okay? So let's find out what t and u are going to be equal to. So I think I can do equation 1 plus equation 2. That will eliminate t. So I'm going to get 1 is equal to 1 plus minus 1 is nothing. 1 is equal to u. So u is equal to 1. If u is equal to 1, I'm going to get 1 minus t is equal to 1 plus 2. So minus t is equal to 2, t is equal to negative 2. So that satisfies equations 1 and equations 2. So now if there is a unique point at which they meet, then these values of u and t will also satisfy equation 3. If they satisfy equation 3, they meet at a unique point. If they don't satisfy equation 3, then they do not meet at a unique point, and therefore they're either parallel or skew. Okay, so bear that in mind for when we do part C. So let's check that they actually do satisfy equation 3. So we're saying 3 minus 2t, so times negative 2, is equal to 4 plus 3 times 1. Well, that's going to be minus 2, that's going to be 7, equals 7. The equation is satisfied. So therefore, they intersect when u equals 1 and t equals minus 2. Okay? And you can even find that point of intersection by merely substituting into one of the equations. Well, I know that I'll use the easiest one. When u equals 1, I'll get x equals 1 plus 2u, so 1 plus 2 is 3. Y equals minus 1 minus 1 minus 2. Z equals 4 plus 3, that's going to be 7. So I know they're going to intersect at the point 3 minus 2, 7. Okay, if I used t and just substituted it into the equation line 2, I'd get the same answer. Okay, so I not only can I show that they're intersecting, I can find that point of intersection. Okay, again, just going to clear some space. Now I can find the angle between them. Angle between them, pretty easy. I'm just going to use this formula. Remember, the cosine of your angle is equal to the dot product of your direction vectors over the product of the magnitude of your direction vectors. So the direction vectors of these two lines are -1, 1, minus 2, 2, -1, 3, over the magnitude of each one, that's 1 squared plus 1 squared plus 2 squared, times 2 squared plus 1 squared plus 3 squared. Okay, so that's -2 plus -1, -2 is -6, whoops, all over, that's 1 plus 1 plus 4 is root 6, and that's 4 plus 1 is 5 plus 9 is 14. Okay, that's cosine theta. So just whack it into my calculator. I'm going to use degrees for this. So the question doesn't say, but we'll assume degrees. So I'm just going to change my calculator setting to degrees. So I'm going to end up with, the numerator is -9 divided by root 6 times root 14. Okay, and then shift cosine of that answer. Okay, and it tells me that that's 169.106. So obviously, remember, there's always two angles between any two lines. There's an obtuse and acute angle. So I found the obtuse. So all I need to do is do 180 minus my answer, and I find out that theta is equal to 10.9 degrees to 1 dp. That's the acute angle between the two lines. Okay, so hope that makes sense. We learnt that before the mock exams. Right, now, show that line 1 and line 3 are skewed. We're going to do exactly the same thing as the first question. No, sorry, part B, where we're going to try and find out what the intersection is, and then we'll show that there isn't one. So line 1 and line 3. So first of all, x equals -1 plus 2s, y equals 1 minus 2s, z equals 1 plus 4s. For line 3, x equals 1 plus 2u, y equals -1 minus u, z equals 4 plus 3u. So let's equate them. -1 plus 2s equals 1 plus 2u. 1 minus 2s equals -1 minus u. And 1 plus 4s equals 4 plus 3u. So we've got equations 1, 2 and 3. Let's solve using equations 1 and 2 by simply adding them. Okay, so if I do equation 1 plus equation 2, I'll get 0 on the left hand side is equal to, just add them, is equal to u, so u is equal to 0. If u is equal to 0, I get -1 plus 2s equals 1, because 2 times 0 is nothing. And so 2s equals 2, s equals 1. So now I need to substitute them, so sub into 3 and see if those solutions satisfy the third equation. So get 1 plus 4 times 1 equals 4 plus 3 times 0. Well, that's going to be 5, and that is going to be 4. It doesn't. Therefore, they are skew lines. Now you can still find the angle between skew lines. Just because they don't intersect doesn't mean there's not an angle between them. And you do it in exactly the same way as we did for part B. Okay? So hope all that makes